Hello, my dear students. In the last class, I explained about the composite bars, how stresses are developed in the composite bars, and how you can find the stresses, right? Today, we will take one more example. A steel rod of cross-sectional area 800 mm square and two brass rods, each of cross-sectional area 500 mm square, together support a load of 25 kilonewton as shown in figure. Calculate the stresses in the rods. Take E for steel as 200 GPa and E for brass as 100 GPa. Okay, this is the given problem. So here you can see there is one steel rod and two brass rods together support a system. So composite bar, as the name itself indicates, it is made up of two or more different types of materials. Okay, so here two rods of brass and one steel rod, which are joined together in such a manner that it behaves like a single unit. Okay, so now what are the given data? Area of the steel rod, it is given, that is 800 mm square. So AS, then area of the two brass rods, right? Here there are two brass rods, so area is 2 into 500 because cross-sectional area of the brass rod is 500 mm square. So it is equal to 2 into 500 is equal to 1000 mm square. Next, total load. Total load is 25 kilonewton. So 25 into 10 raised to 3 Newton. Okay. Then Young's modulus for steel is given, that is 200 GPa. What is 200 GPa? That is equal to 200 into 10 raised to 9 Newton per meter square, or 200 into 10 raised to 3 Newton per millimeter square. Right. Next, E for brass as 100 GPa. Okay, so this also you can convert into millimeters. So it becomes 100 into 10 raised to 3 Newton per millimeter square. Then length is different here. The length of the brass rod is 250 mm and length of the brass is 200 and the length of the steel bar as 250 mm. Okay, you can see here these two are of length 200 mm and the steel is of 250 mm length. Okay, now we have to find the stresses in the rod. So let us consider sigma S is stress in the steel rod and sigma B is stress in the brass rod. How we can calculate stresses? As I told in the last class, you have to remember 2 points while solving the problems. What are those? First point is the deformations are equal in both the rods, and second point is the total load, that is equal to the sum of the load shared by the rods, right? So first we will consider the first rule, that is deformations are equal. So first find the deformation of the steel rod due to the stress. What is deformation? All of you know now deformation is equal to PL divided by A into E, correct? Deformation is equal to P into L divided by A into E, correct? This is deformation. Now we are finding deformation for steel rod. So this is delta LS, right? Now how you can write P by A? Stress is equal to load divided by area. Correct. So now this is for stress in the steel. So I'll take sigma S. This is PS and AS. So this is PS and this is also AS. So what is PS divided by AS? This is nothing but that is equal to stress sigma S. So that's why I've written here sigma S into this is LS. So that LS divided by E into S, right? So write that and substitute the given value. Sigma S we don't know, into LS. What is the length of the steel bar? That is equal to 250 mm. Okay, substitute, and ES, Young's modulus for steel, is 200 GPa. So that is nothing but 200 into 10 raised to 3. Okay, simplify this. You will get this equation. This value. Okay, next find what is the deformation in the brass rods due to the stress. Again use the same formula. Deformation is equal to PL divided by A into E. Okay, here it is for brass rod, so it is PBLB divided by AB into EB. So what is that? P divided by A is sigma stress, so stress in the brass rod, that is into LB, because length of the brass rod, divided by Young's modulus for the brass. Substitute the given values. You get this simplified equation. Okay, so what the rule says, the deformations are equal. So substitute these two equations. Let it be, this is 1, equation 1, and this is 2. Okay, so equate these two, 1 and 2. What happens? 1.25 into 10 raised to minus 3 sigma s is equal to 2 into 10 raised to minus 3 sigma p. Simplify this, you get the answer sigma s is equal to 2 divided by 1.25 into sigma b, or if you simplify that, you get sigma s is equal to 1.6 sigma b. You can write in terms of sigma b also, no problem. Okay, I have written here in terms of sigma s, so this is nothing but equal to sigma s. Okay, what is the next point? The total load is equal to the sum of the load shared by the two rods, right? So that is nothing but P is total load, that is equal to, here two rods are there, P S and steel rod and brass rod, right? So I write here PS plus PB. What is PS? P, how you can write? P is load, stress is equal to load divided by area. So how you can write? P is equal to stress into area. So that's why here it is written sigma S into AS, that is PS plus PB is sigma P into AB. So what is sigma S? Sigma S is equal to 1.6 times of sigma B. So substitute that into AS, area of steel, that is equal to 800. So substitute that 800 plus sigma B we don't know, let it be like that only, into AB. What is area of brass rod? Two brass rods are there, so 2 into 500 is equal to 1000. So substitute. So only one unknown, that is sigma P. Okay, when you simplify this, you get sigma P is equal to 11.0 Newton per millimeter square, or 11 megapascal. Okay, you know now sigma P. How you can calculate sigma S? You know the relationship between stress in the steel and brass, that is nothing but sigma S is equal to 1.6 times of sigma B. So substitute that sigma B value in this equation. So what you will get? 1.6 into 11, right? So that is equal to 17.6 Newton per millimeter square, or megapascal. Okay, like this way you can calculate what are the stresses developed in the brass rod as well as the steel rod. Main thing you have to remember the 2 points, that is the first point is deformations are equal. So you have to equate the two deformations and then write the equation in terms of any one of the stress. It may be a sigma S or it may be sigma P. The next step is the load. The total load is equal to load shared by the two rods. So P is equal to PS plus PB. So what is P? P is a load. So stress is equal to load divided by area. So load is equal to stress into area. So substitute that, you will get like this equation. So substitute all the values whatever you know. So only one unknown will be there. So you can find what are the stresses developed. So in this this is the way to calculate the stresses developed in the composite bar. Okay, so next class we will solve one more problem. I think all of you understood this. If you have any difficulty, we can discuss in the class. Okay, thank you.